In this module, we look at text and image file formats. We'll start by looking at text-based documents, and to do that, we'll use Google Docs. What you're seeing is a live session with Google Docs. You get to Google Docs by going to docs.google.com and logging in with your Google username and password or your URI email username and password, since URI email is Google-based. If you're in Gmail or one of the other Google applications, you can also get to your documents by clicking on the Documents link that appears across the top. Here I'm in Google Docs, and what you see are any documents that you've either created in Google Docs or that you've uploaded from your computer to the Google Docs space. Here I have one document that I uploaded. You can create new documents in Google Docs by going to Create New and choosing what you want to create. We'll be creating a document, but before I do that, let's look at the other things you can create. You can create a presentation, which will create a document like a PowerPoint presentation, similar to what I used when I introduced the course. You can create spreadsheets, like a spreadsheet created from Microsoft Excel. And you can create drawings. We're going to be looking at text-based documents, so we'll create a document. So I'll choose Create New Document. Up will come the document processing software in Google Docs. It looks and acts a lot like Microsoft Word, but without all the features. We're actually here in a browser. I'm in Firefox looking at the creation of the document. Now Google Docs has its own menus. So here's a file menu in Google Docs. In the file menu I can create new documents. I can open existing documents that have been uploaded to that Google Docs space that I showed you before. I can upload new documents from my computer to that Google Docs space. I can rename files in the Google Docs space, copy. After I've created files in Google Docs, I can download them to my computer and choose the format that they're downloaded into. So we're going to demonstrate that in a few moments, how I'm going to create a simple text document and download it in different formats, and some of the different formats that Google Docs allows. PDF is a canonical document format that's independent of word processing. RTF is rich text format, and it's again independent version of a word processing document. Plain ASCII text is simply the characters you type without any formatting. And in other modules in this course, we look at ASCII text, simple typed characters. And if you download your document out of Google Docs as text, you're getting only the typed characters. You can also save it in Word format, and we'll be talking about the difference between Word format, which is Microsoft's Word's application format, and text. But you can save a Google Doc as if it were a Microsoft Word document, meaning that on your personal computer, if you had Microsoft Word, you could open it. And you can save it as a web page, which is the HTML format. So again, the idea here is that we're going to create a document in Google Docs, and it will reside in Google Docs as a Google Docs document. But we can download it to our computer as a PDF, text file, Word file, web page, different ways of viewing the same document we create in Google Docs. Continuing with the menus, we can save things as we type. Google will save them periodically itself, but you can save it if you hit an important point to do a save. Looking at the Edit menu, you can undo and redo in Google Docs. You can cut, copy, paste, select all, find and replace. Again, if you look at the editing capabilities in Microsoft Word, there will be a lot more capabilities that Microsoft Word provides. But Google Docs provides the important ones, and in some sense keeps it simpler. The View menu allows you to view things like comments that you put into your word processing document. Insert allows you to put into your Google Docs text-based document things besides text, like images. So you can have images on your computer that you upload and put in to the Google Docs document, much like you would insert an image into a Microsoft Word document or a PowerPoint presentation. You can put links into your text so that you can link off from your Google Docs document to web pages on the internet. You can create equations and drawings, put in comments that aren't viewable when the text is printed but are there for authors that are sharing, for instance. You can put in footnotes, special characters. You can have headers and footers on your document. Again, the templates and the formatting capabilities aren't as extensive as Microsoft Word, but the basic things that most people do are here in Google Docs. For formatting, you have bold, italic, superscripts. You also have icons for these across the top for convenience. You can set line spacing. You can do alignments for left and right, center, this kind of thing. There are some tools, translating the document, word count. The table menu allows you to insert tables. So you can insert tables of various sizes. Once you have a table, you can insert rows and columns. So again, the capabilities of Google Docs aren't as rich as Microsoft Word, but most of the important things are there. And the look and the feel, the icons used, are similar to that of Microsoft Word. So if you've never used Word before, you're going to see how to use Google Docs. Moving into Word should be a smooth transition for you. And if you've used Word and word processing before, then working in Google Docs should be a smooth transition for you. So I'm going to enter some text into this text-based document. I'll put my name, which, including the space between Vic and Feywolf and the hyphen, I just typed 13 characters on the keyboard. Now in another module in the course, we talked about how characters are represented in the computer, that each character is 8 bits or 1 byte represented in the ASCII code. So when I typed Vic Feywolf, those 13 characters generated 13 bytes of text. And we're going to see that this simple text that I typed can be represented in different formats. PDF format, doc or docx format for Word, or as a simple text document. In all documents, those 13 characters will be in all of those formats. As a text document, only those 13 characters will be there. In Word, PDF, and other formats, those 13 characters will be accompanied by other characters that establish things like margins and formatting and other data. So notice that the status of the document is saved. So Google saved it for me, and it said it saved it seconds ago. I can also force it to save by going to saved here, but you can see since it was saved and nothing was changed that it's not available to me. So now it's been saved. So now what I'm going to do is I'm going to download it to my computer in different formats. So it exists now in Google Docs. So if I go to my main documents tab and I view documents by type to see Word or text-based documents, I see that there's a untitled document that I just created. I can give that document a name by going to the File menu of the Google Docs document processing software and choosing Rename. And I'll give that document a name. And click OK. So right now it's stored in Google Docs' own document format. And I'm going to download it to my computer. But first, let's see if the name did indeed change. So I'll go across the tabs of my browser and go back to the window in Google Docs that had the documents. And we see that it's now called first.txt in this document storage space here on Google Docs. So going back to my browser, and going back to the tab to actually go to the word processing software in Google Docs, I go back to it. Now I want to take this document from Google Docs and move it to my computer. And I want to specify the format. So I'll go to the File menu and choose Download As. First, I'll download it as a PDF. It says, what do you want to do? Do you want to open it on my personal computer, or do I want to save it? So I'm going to save it. And it's downloaded and saved. Now I will download it in a different format. So I'll now download it as a text document. Remember, text means that there are no special formatting, it's just the characters that I typed. So I'll download that as a text document to my computer. What do I want to do? Open it or save it? I'll save it. And Firefox sends it to the downloads folder for me. But now it's called firsttext.txt. I had previously downloaded firsttext.pdf. So 2 files have been downloaded from Google Docs to my computer. Let me download it a third time. Download as a Word document. Save it. And downloads as firsttext.doc. Now I'm minimizing my browser. I'm now on my personal computer. My personal computer is a Windows 7 computer. And when I use Firefox, Firefox downloads to the user I logged in as in the Downloads folder. So I see in my Downloads folder the 3 versions of the file that I downloaded. Firsttext.doc. Now on Windows it doesn't show the .doc, but this is the .doc version, a Word document. Firsttext.pdf is a PDF document. And firsttext.txt is the plain ASCII text document that I downloaded. All 3 of them, when I open them, contain the same thing. So let me open FirstText. I double click it, and on my Windows 7 machine it'll run Microsoft Word. So I'm running Microsoft Word. Again, if you haven't seen Microsoft Word's interface, note that it looks a little like the Google Docs interface with icons and menus here, except that it's a much more feature-rich application. So there's all kinds of styles that you can do. There's all kinds of more fancy formatting that you can do. But again, Google Docs has the basic things that most people use. So when I open it in Word, I see it just has my name, the 13 characters I typed. Okay, so I can close Microsoft Word. Let's go back and look at FirstText now, firsttext.pdf. When I double click it, it runs an application on my computer called Adobe Acrobat Reader. Adobe Acrobat Reader is software from a company called Adobe to read PDF files. And there's versions for Macs, PCs, and other platforms. So now I'm in reading firsttext.pdf in the Adobe Reader. Again, it just shows the text I typed, just like Word did. So closing the application Adobe Reader, I now click on firsttext.txt. So remember, this is firsttext.doc, firsttext.pdf, and this is firsttext.txt. I double click it. On my Windows computer, it runs an application called Notepad, and it shows me what was in the file. And again, it looks like the text that I typed. So the point is that the text I typed looks the same in the Word document, the PDF document, and the simple text document. However, there are differences. Let's look at the size of each of the files, size and how many bytes there are in the file. To look at firsttext.doc, I hover over it in Windows and I right-click to choose Properties. Now the HelpFac link on the course website shows how to get file sizes in Macintoshes and other operating systems. I'm in Windows 7, so to get the file size in bytes of first.txt, I hover over it and I right-click my mouse and choose Properties. And it tells me that the size of firsttext.doc is 9.5 KB. From another module we talked about KB being kilobytes. So 9.5 means 9,500 bytes is the size of first.txt. Let's take a look at first.text.txt. I right-click it and choose Properties. And I'll put it up here next to firsttext.doc. Firsttext.txt size is 16 bytes. Which is the 13 bytes of the text of my name, presumably with 3 extra spaces that I must have typed at the end. But the point here is that The size of test text.txt is just the number of bytes for characters I typed, 1 byte per character, 16 bytes. Whereas the same thing that shows up in Microsoft Word as just my name takes over 9,000 bytes. The difference is something called metadata, M-E-T-A. Metadata is stored in firsttext.doc. It's not stored in firsttext.txt. Metadata is data about the data in the document. Things like, is it bold? What are the margins? What date was it created? Microsoft Word keeps an incredible amount of metadata in the file along with the text you typed. So in firsttext.doc, there are 9,000 some bytes of metadata describing things about the document. In firsttext.txt, there's just the ASCII bytes for the text that I typed. So sometimes you'll hear people refer to text files with the .txt extension as simple text or raw text because it has no metadata with formatting. It's simply text. Text has its place. It's universal, so it can be used in email and to create web pages, whereas .doc files are unique to the Microsoft Word application. Now other applications such as Google Docs, OpenOffice is another application that's freely available for personal computers. These applications can read and write .doc format, so they know how to put the metadata in that Word requires. But unless you have an application that knows how to read and write .doc or the next version from Microsoft called .docx format, then your computer can't interpret the document. Whereas if it's just text, all Word applications, all word processing applications and Internet applications can interpret text documents. To demonstrate metadata, let me look at firsttext.doc. So firsttext.doc is a Word document. If I double-click it, it'll run Microsoft Word. But I can also open it with another application on my Windows computer. So by hovering over it and right-clicking and choosing Open with Notepad, I'll open the Microsoft Word document in Notepad. Notepad is a simple text editor. It doesn't understand all the metadata of Microsoft Word. So when I open it in TextEdit or in Notepad, it shows me all the meta characters as these kind of funny characters here. It doesn't know what they are because Notepad thinks everything should be simple ASCII text. So what you see here is the vast amount of metadata that Word stores. Now some things are readable. For instance, here we see Times New Roman. That's the font that Microsoft Word would use to display the document. And that could be other. It could be Helvetica or other fonts. Now, simple text has no notion of a font, but since this is a Word document, the font has to be stored in there. We also see here's some of the text that I typed, so my name is actually in there. So the ASCII of my name is there. It's just that there's all of this other stuff there that is the metadata of a Microsoft Word document. To kind of complete talking about Microsoft Word documents, notice that when I hover over it, it says it's a doc file. That means it has the extension .doc. The newer Microsoft Office documents save things in a format called .docx. .doc was a format for Word through Word 2003. Word 2007 started saving by default as .docx. The difference between .doc and .docx is that .docx is compressed. So another module in this course talks about compression. .doc had very large files with lots and lots of metadata. Many of the fields of the metadata were simply blank, but they had to be there anyway. .docx took those patterns and compressed them using the same compression technology as a .zip archive that we'll be looking at. So, in summary, Word documents have two formats. .doc, which is an older format, is uncompressed, and .docx, the newer format, is the .doc format but compressed. And let's look at the PDF as well. So we saw that first text.txt is 16 bytes. Let's see the size of the PDF. So I right-click on first text.pdf and choose its properties. And let me move it over here. So first text.txt we saw was 16 bytes. First text.pdf is 14 kilobytes. So it's 14,000 bytes. It's got even more bytes than the Word document. Again, what we're seeing, these extra 13,000 plus bytes are 14,000 plus bytes are the metadata in a PDF document. So again, PDF documents have formatting. They have whether it's bold, what the margin sizes are, and all of those things require data that makes the size of the file larger. Again, the PDF, when we viewed it, simply had my name, but it was stored with 14,000 bytes, whereas the simple text version was only 16 bytes. Now that we've looked at basic text file formats, we're going to look at image file formats. To do that, we're going to use a piece of software called GIMP. GIMP is a free application made to look and act a lot like Photoshop. GIMP is freely available for Macintoshes, Windows, and Linux platforms, and many of our course websites have a download link to GIMP on them. If not, you can Google for the GIMP application and find the download. GIMP looks and acts a lot like Photoshop, and it's based on the same concepts. So one of the reasons we show you GIMP is that the concepts you learn in GIMP are easily transferable to working in Photoshop. Now today I'm not going to go into the extensive capabilities of GIMP. We do that in a module in the CSC 101 course. Today I'm just going to be using GIMP as a basic drawing tool to create an image so that I can show you some file formats. And GIMP is not designed primarily as a drawing tool. It has drawing capabilities in it. But GIMP's main purpose is to manipulate images, take JPEG images, say, off a digital camera, and create really good image manipulation capabilities so that you can create really neat images. But I'll do a simple drawing today. So what you're seeing here is GIMP's interface. I've downloaded GIMP to my personal computer and run it. It presents a tool palette similar to a tool palette you would see in Photoshop, and the tool palette are some of the things that you can do to images in GIMP. It also has a window for the image itself that has menus across the top. And the menus have even more extensive capabilities for things you can do to images. To create an image to demonstrate file formats, I'm going to go to the File menu here and choose New. And you can specify the size of the window. I'm just going to leave the default size for now and say OK. And I get another window that I can work with an image in. To make my drawing, I'm going to move over to the tool palette and choose the paintbrush tool. You see that if you hover over the tools, it shows you what the tool is. So I'm choosing the paintbrush tool. I click on it to select it, and I will come over here and I'll make a drawing. So I'm clicking and holding my mouse and moving my mouse in the pattern that I want to have for the drawing. Once I have my drawing, I need to save it in an image format. So I go to GIMP's File menu and choose Save As. Up will come a dialog box allowing me to name my drawing. So I'll name it First Image. Specify the folder to save it in. I'm going to put it on my desktop. And select the file type. Notice the little plus sign here. So you hit the plus sign and it gives you some of the different file types that you can save your image in. By default, it's saved in an XCF format, which is GIMP's own format for images. But we're going to save it in some of the more typical image formats that you're going to work with. So first, let's save it as, scrolling down, a Windows BMP image. This is a bitmap image, and bitmap is discussed in another module in the course. It's the image format that saves every pixel of the image as 1 or more bytes. So let's save this as first image, and by selecting the file type as BMP, notice that GIMP will add .bmp as the file extension. So I'm saving my little drawing as firstimage.bmp to my desktop, and I click Save. If I minimize my GIMP window, move this over a little bit, we can see on the desktop, here's firstimage.bmp that I saved from GIMP. Bringing GIMP back up, I'll take the same drawing and do another save as. Keep it called first image, but now delete the .bmp, have it go to my desktop, and I'll select a new file type. This time I'll save it as a JPEG image. So it'll be called, not FIRD, but almost first, FIRT image.jpg going to my desktop. When you save something as a JPEG, before you can save it, up will come this dialog box, and it asks about the quality of the image. And there's a slider. The farther right you slide it, the higher quality of the image you get, but the less compression you get. Another module in the course talks about how image compression is done and how when you choose to have less compression, it finds less patterns. And if you have more compression, it kind of gloms in pixels into patterns, and in doing that loses some clarity and accuracy in the picture. Typically for JPEG, for printing and putting things on web pages, 60% quality is a good level in that you don't lose much accuracy or clarity, virtually imperceivable to the human eye, but you get good compression. And you can play with the quality levels if you don't like what comes out of it, but typically 60% is a good quality level. So I'll save that. And now when I look on my desktop, I see two, firdimage.bmp, which is the one I saved a few minutes ago, and firdimage.jpg, which is the image that I just saved. Now we look at the file sizes of those two images. Again, I'm on a Windows 7 computer. So on a Windows 7 computer, to get the file size, I hover over it. This is firstimage.bmp. I right-click and choose Properties. And I get one dialog box. Again, if you're on a Macintosh, you need to go to the course website and look at the help fact to see how to get file sizes for files on Macintoshes. You right-click here on firstimage.bmp and choose its properties. And let's put them next to each other. We see that the file size of firstimage.bmp is 750 KB, or 750,000 bytes. We see that the file size of the same image, the same little smiley face, as a JPEG is 11.7 KB, or almost 12,000 bytes. So it's 12,000 bytes for JPEG, 750,000 bytes for bitmap. The reason is, as was covered in another module, lecture on another module of the course, bitmap images are uncompressed. So every dot of that smile face is saved in the bitmap. So taking a look at the smile face image, the way the bitmap was created was that every pixel, all this white up here, each pixel has a byte or two or three or four saved for it. So it's saving white, 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 white. All of these bytes are being saved until it gets to some byte where there's some black in it, and then it'll save a different pixel. But a vast majority of the pixels of this drawing are just white pixels, and the bitmap has to store a code for white pixel over and over and over again. Whereas a JPEG image would note that there's a huge pattern of white pixels and simply put in the pattern white and the number of times to repeat it. By doing that, it doesn't have to take anywhere near as many bytes to store the information about the image. And we see that when we look at the file sizes. 750,000 bytes means that there's 750,000 pixels in here, most of them white, a few of them black. Here, they were able to, for JPEG, it was able to use just 12,000 bytes to store the same image, information about the image, possibly losing a little quality here and there, but not quality that's perceivable to the human eye when it's, say, put on a web page or printed. There are other important file formats like GIF, which is also compressed, and PNG, which is also compressed, and GIMP can save in those file formats as well. We'll now look at how another form of compression, general file compression using zip, is done. If you have a Word document, or actually any file, and you want to compress it, which means get the file size smaller, but when you use zip compression, you're doing it without losing any quality. Zip is what's called lossless compression, so it stores the patterns of the bytes, but makes it such that there's no quality lost. So, looking at this Word document, if I right-click it and choose Properties, we see that its size is approximately 34,000 bytes. If I create a zip archive for it, it will compress the file down as much as it can. Zip archives actually serve two purposes. One is to compress any file that you put into the zip archive. The second is that a zip archive is a single file into which you can put multiple files, each being compressed when it goes in. So in some sense, a zip archive is like a container into which you can put other files. The result being a single file, all compressed, that contains all the other files. In many of our courses, we ask you to turn in a single zip file when you've generated multiple files for an assignment. So, for instance, in an image assignment, we might have you take an image and generate multiple versions of it, but then to turn it in, we'll have you put it into a zip archive and simply turn in the single file, which is the zip archive. To create a zip archive on Windows 7, you right-click or you hover over it and right-click. The course website Help FAQ discusses how to create zip archives for Windows 7, different versions of Windows, and for Macintosh. I'll demonstrate it here for Windows 7, but if you're on a different platform, then you want to go to the course Help FAQ on the website to see how to create a zip archive for your platform. So again, on Windows 7, we hover over it, and I'm going to right-click and choose Send to Compressed Folder, and you can see it even says zipped here. So I'll do that, and it's going to create another folder for me called, the original Word document was called TA Training. This is called tatraining.zip. This is tatraining.doc. This is tatraining.zip. If I double click the single file called tatraining.zip, it opens up as if it were a folder, and we see the original Word document inside. This document is compressed. If I look at the file size of tatraining.zip, which remember contains tatraining.doc, we see that its file size is almost 7,000 bytes, which is much smaller than the original Word document, which was 34,000 bytes. The beauty of zip is that the information is still there. The Word document is exactly the same, it's just compressed with lossless compression from 34,000 bytes down to 6,000 bytes. The other thing about zip archives is that they can contain more than one file. So for instance, say I had done a lab where I was supposed to turn in the two images that I made, FerdImage.bmp and FerdImage.jpg, along with the Word document. I could simply drag the other files that I want to put into the archive over this thing that appears to be a zipped up folder, which is really a single file called, in this case, tatraining.zip. Now I look inside the archive and I see that all three are there. This is one file, although it looks a little like a folder on Windows, but see the zipper. One file called tatraining.zip that contains three other files. Typically we have you, when you're turning something in, name it, so I'll rename this to, say, homework1.zip, and now it's a single file, homework1.zip, containing three other files that I generated, say, presumably in the homework, and I would upload this file in whatever way is specified for turning in assignments in the course. This concludes our look at text and image file formats. And you'll be using those concepts and kind of some of the skills like zipping up things throughout the course.